Yeah. Hello and welcome to Seepage Face and Groundwater Waves with Dion and Harry. This project was supervised by Shokri, and I will pass it on to Dion for Seepage Face.
Yep, in this project, we looked into mainly seepage faces and groundwater waves. Seepage faces are points where groundwater flows out of the ground. Knowledge about this is important in many fields, such as hydrogeological and geotechnical engineering, as it can greatly affect the environment and any constructions done. One of the purposes of our investigation was to model seepage faces to try and find equations to more accurately represent them, as this will allow for more accurate data on an area to be gathered prior to the construction of a structure, allowing for them to be more accurately designed and allowing them to have a longer lifespan, be more sustainable and safer. To do this, we filled a flume with soil and set about creating a seepage face under different environments, angles, and types of soil, recording the results and using these to model the seepage faces to try and find more accurate equations to represent them. So far, we have successfully modeled the seepage faces. However, we have yet to find a more accurate equation for modeling them than the ones that already exist. Now I'll pass over to Harry for groundwater waves.
So a groundwater wave is a change in the water table where we see a periodical fluctuation. Instead of on the surface of the water, it's in the groundwater. And they have been seen in coastal aquifers, but we intended to model them ourselves using a mechanism. So we basically used a flume. We filled it with sand, and we wanted to utilize our inlet and outlet to run water through it. And we constructed a rectangular shaped sand earthen dam. We used a pump with a water basin and pumped water through from the inlet. And we were able to get the seepage face measurement. And then we went on to the groundwater wave testing. We used along with this, we used a car jack to change the angle of the flume, which is a variation of what we're trying to do from the control test, which is just a regular flat test. And the results showed that after a 30-minute test, when the inlet was rapidly dropped, the water level at the inlet, that was our way of trying to produce a wave in the ground, in the sand. The data shows once the 30-minute test was completed and the water level was dropped, there is a hump. You can see in the first data set on the graph, there is a bit of a hump, although it's a static hump, so it's not oscillating or moving along. In the second test, we saw 2 of those. There was a bit of a flaw in the test. There was a sand blockage causing the water level to be fluctuating like that, but we still do see waves there, but they're only static waves. And that's groundwater waves. Thank you.
Thanks for listening to our presentation. Thanks.
And yes, thank you for listening to our presentation on seepage face and groundwater waves with Shokri, Dion, Herniman, and Harry Green.